Let's look at the analysis of match data. In this table, we can see a summary of analysis we can do in SAS to analyze match data. We go from the simplest analysis of the McNemar's test in proc-freq with the McNem option, all the way to conditional logistic regression using proc logistic with a strata statement, where we can account for the match design and also adjust for different variables. Let's start with the McNemar. So again, we can have examples like the right and left eye, the husband and wife, before and after. These are all examples of matching. So if we want to do a crude analysis, we can do a McNemar's test or a Cochrane-Menton-Henso test, and we will get a similar p-value. If we want to calculate the odds ratio, we can do a stratified analysis using the and calculate the odds ratio Menton-Henso test or conditional logistic regression. In both cases, we will obtain an odds ratio with 95% confidence interval. So let's take a look at an example. Here we have 95 patients who receive acupuncture on the left foot and placebo on the right foot. First, can you think of something better that we could do? Well, one way to improve the design would be to randomize to either the right or left foot, so that we don't always have the left foot receiving the acupuncture and the right foot receiving the placebo. What you want to be careful at is how to set up the table. This is done differently than if you do it in an unmatched design. So let's take a look at the numeric example. You can see that the table layout is very different. Here we have the exposure that is present. Here is like the left foot, we have the acupuncture needle, or the unexposed would be the foot with the placebo. The outcome is present on both, yes or no, whether there is a response or not. And we have 95 individuals. And the question would be, is the proportion of left feet responding to acupuncture the same as the proportion of right feet responding to a placebo? You can do a McNemar's test if you want to get a p-value. To conduct a McNemar's test, you will ignore the concordance cells. This will be the cells A and D. Will be these cells right here. These do not provide any information. And in fact, if you have a very large number of these cells, you're not going to get much better power. Then you're going to use this formula, B minus C squared divided by B plus C. And you will get a value. This is your test statistic, which is approximately chi-square distribution with 1 degree of freedom. So you can look up this value on a Z or a chi-square table. In this case, we have a Z table. We take the square root of the chi-square and we obtain the Z value. We look up, it's 1.86, which corresponds to a two-sided p-value of 0.629. We can repeat the same in SAS. Here you can see the data step. We'll put the $sign in front of placebo and treatment because these are character variables. It's a yes or no. Instead of writing 10 lines, we will write 10, and then we are going to use that as a weight, which will be the same as writing 10 lines, 25 lines, 40 lines, and 20 lines, but this is a shortcut. For a small n, we will use the exact McNem. Otherwise, we can just simply use the agree option. And this is the result. Make sure that the table looks the way you want it. And you can see that the outcome is present both in the rows and in the columns of the table. This is different from a traditional 2x2 table. The concordant cells, where both the right and the left foot respond, are 10 and 20. 20 neither foot responds, and 10 both feet respond. So those do not count for anything. And you can look at the p-value, which is very similar to what you had before. Compare this to what you saw using the z-table.